following has been developed by state and provincial educational agencies in association with the Agency for Instructional Technology, together programming for today's learner.
They're beautiful.
Yeah.
It's getting pretty crowded in your aquarium, Dawn.
Yeah.
When you bought the new fish, I noticed the store's having a sale on aquariums.
Yeah?
Do you want to go look for a bigger one?
Yeah.
Wait a sec, Dawn. Don't you think we should at least figure out the volume of this aquarium?
Volume?
Volume is an amount of space. If we measure the amount of space, we can make sure the new one's bigger.
We'll be able to see which one's bigger.
Are you going to get the same shape?
Probably I'll just get a rectangular one.
Then for sure we ought to measure the volume of this one. Their shapes will be so different it'll be hard to decide which contains more space.
How do you measure this volume stuff?
Let's scoop the water into the sink and count how many cups it takes to empty it.
What? My fish will think we're trying to drown them.
So Shirley seems to be having a problem getting the idea of volume across to Dawn.
Everybody knows what volume is.
Yeah, what?
It's the little knob on the stereo that you crank up to blast people. Seriously, as Shirley said, volume is the amount of space.
So with an aquarium, is that the same amount of water inside it?
Close, but the fish and air and rocks and everything take up space too.
Yeah, I guess fish do take up space.
Sure, so do you.
So with an aquarium, the volume is the total amount of space inside it.
Right, and Shirley's right. They could measure the volume of the fish tank by counting how many cups of water it takes to fill it.
See one you like?
Yeah, and it's on sale. I told you we'd be able to see which one's bigger. Whoops.
Hey, how about one of these?
I can afford this one.
But it's not any bigger than your old one.
What do you mean? Look how wide it is.
Yeah, but look how short.
Well, I can tell it's bigger. Anyway, my fish won't have to swim up and down so much.
Yeah, but they'll have to keep looking at each other.
That's all right. They're old friends.
Let's at least figure out its volume.
What, are we supposed to sneak it off into the bathroom?
Okay, first off, I figured out a better way to measure the volume of your tank. We can scoop the cupfuls into your mom's big turkey pan.
What? My fish will think we're trying to cook them.
I got it. We'll use my mom's big punch bowl. Fancy glass. They'll think they're in heaven.
Yeah, but we can't go scooping water into this one.
I think there's a better way to measure the volume of this tank in our heads.
You're not scooping anything into my head.
No, I mean by measuring the length in every direction and calculating.
Oh, yeah. It's a formula, right?
Right.
Okay, this tank looks about 30 centimeters wide, don't you think?
Yeah, about that. Maybe a little less wide.
And about 20 centimeters high.
Yeah, I'd say.
Okay, so 30 times 20 is 600. The volume of this tank must be about 600 square centimeters.
That's not volume you measured, that's just area. In fact, that's just the area of this one side.
You want the other sides? I'll measure them. This looks about 20 centimeters wide and 20 centimeters high. So 20 times 20 is...
What, are you going to measure all the sides?
Yeah, if it'll make you happy.
Look, Dawn, you can measure every side and the top and the bottom. But what about this?
Look, I can tell that the new one's bigger. Trust me.
A fool and her money.
Are soon parted.
Wait a minute, Dawn may be right.
Does the new tank look bigger to you?
Maybe.
Well, if you were in Dawn's place, wouldn't you at least measure its volume?
Well, yeah, but I know the formula for measuring the volume of a rectangular prism. It's a box shape, a shape that's rectangle on all sides.
What is the formula?
You want me to just tell people? You'd rather figure it out yourselves, wouldn't you?
Well, why don't we give them a clue?
Okay, how about this? The area of a rectangle equals the measure of length times the measure of width.
And you measure area in square units. Picture the squares covering a surface.
But volume is three-dimensional. It doesn't just cover surface, it fills space.
So you measure volume in cubic units.
Hey, Ed!
Hi, Mr. Barnaby.
Oh, hi, Gina. Where's your dad? I'm kind of a hurry.
He went to get the car fixed. He left me in charge while he was gone.
Yeah, how many baseballs does he want?
Well, he wants you to fill a shelf. Can I show it to you?
Yeah, okay, but I'm running late.
Here it is.
Fill that shelf, huh? Maybe a dozen boxes. Each box has 24 balls in it.
Well, Dad said to be sure not to buy any more than we need to fill the shelf.
Okay, I'll bring you 5 big boxes.
Well, he said to be sure to get plenty. We're having a big sale.
Yeah, look, Gina, I've got 11 more stops to make this afternoon.
Well, could you just bring in some boxes, then I'll figure out how many more we need?
Yeah, how many?
Start with 5.
How many more? Please, Gina, how many?
How about 3 more for now?
Yeah, for now. Look, I'm really running late.
Hi, Gina.
Can't talk, Henry.
What you doing?
I gotta figure out how many of these boxes to buy to fill this shelf.
Doesn't sound so hard.
You try it.
24 baseballs in a box. You just find out how many baseballs the shelf will hold and divide by 24.
I know that. The problem is to figure out how many baseballs it'll hold.
I got it. I know an easy way to figure it out.
5 and 3 make 8. Is that enough?
Please, Mr. Barnaby, could you just bring the bats in and make out the bill? Then I'll tell you exactly how many more we need. I promise.
Oh, okay.
So what's your bright idea?
Can I come back there?
Move it.
Okay, make a stack up here. Okay, count each way for me.
Okay, 9 across the back, 6 down the side, and the stack is 9 high.
486 divided by 24 equals 25. You need about 20 boxes.
Last chance, Gina. Do you need any more?
20 minus 8 equals 12 more boxes, please, Mr. Barnaby.
All righty.
What'd we just do?
We figured out the volume of the shelf, the space inside, in terms of cubic baseball boxes.
Yeah, but how did we do that?
Well, we multiplied the number of boxes in the height and the number of boxes in the width and the number of boxes along the length, and that gave us the volume in cubic boxes.
Whoa. Okay, I know that the measure of length times the measure of width gives you an area.
Right, and when you multiply that by the height, then you get the volume.
So you measure the volume of a box shape by starting out as if you were measuring the area of one side.
Right, you multiply the length times the width.
But then you multiply it again by the height.
Right, that's the formula for measuring the volume of a box shape. Volume equals the measure of the length times the measure of the width times the measure of the height.
And you measure that in cubic units.
Right. How many cubic baseball boxes do you see?
6.
3 long times 2 wide times 1 high equals 6.
Right.
Now how many?
3 long times 2 high times 2 wide equals 12 cubic baseball boxes.
Right. Now how many?
3 long times 3 wide times 3 high equals 27 baseball boxes.
27 cubic baseball boxes.
Right. Could you measure the inside of the fish tank that way?
Well, you could. At least a fish tank that's a box shape.
Of course, the baseballs might not fit just right.
Probably the best way to measure the volume of a fish tank is to use standard units, like centimeters or inches.
Yeah, then you'd measure the volume by multiplying the measure of length times the measure of width times the measure of height.
Right, and that would give you cubic units of volume.
Speaking of a volume problem, we have one here at the Great Salt Lake.
This is Dr. Wally Gwynn, a geologist with the state of Utah.
Dr. Gwynn, could you please tell us what has happened?
Yes, we've had a big problem here at the Great Salt Lake in the last few years. As you can tell from the restroom behind us here, the restroom was built a number of years ago, well above the water level. But within about the past 4 years, the water level has come up about 12 or 13 feet. The Great Salt Lake has been rising because we've had an increased amount of precipitation. We've had a little bit cooler weather, and this means that we have less evaporation. The hydrographic chart is a way in which we can represent how the lake comes up and down with time. Back in about 1963, the lake had been coming down and down and down to its historic low. And at that time, people were wondering, is the lake going to disappear? And that's funny because now we're way 21 feet above that, and people wonder if it's ever going to stop coming up. Because as the lake comes up, it also spreads out. The lake has been spreading out. It has been covering bird refuges. It has been covering highways. It's been covering homes near the lake. In fact, the area of the lake has just about increased by 2 times since the early 1960s. As you look at the historic low, the lake is not very big. But as the lake has come up to kind of an average elevation that we have run at, you can see that the lake has expanded in size quite a bit. We also see that the historic high is much larger. We take the average area in 1962, the average area in 1986, and we take an average of those two. And then we multiply that by the height, the additional depth of water. And that gives us the volume of the lake, or the change in volume. Its volume has increased somewhere around 3 times what it used to be. That much water would be a foot square column reaching to the moon and back again about 51 times. Or it would be enough water to cover an area the size of Utah to about 4.5 inches, or an area the size of Rhode Island to about 27 feet.
So volume is an amount of space?
And you can measure the volume of a box shape by multiplying the measure of length times the measure of width times the measure of height.
But all that volume tells you is the number of cubic units in a space. Entirely different shapes can have the same volume.
Really?
Yeah.
So every one of these shapes has the same volume.
Same number of cubic baseball boxes, right?
Right. Then shape in itself doesn't tell you anything about volume.
That's right. And sometimes appearances can be deceiving.
You sure you don't want to measure the volume of both tanks? I can get my mom's bowl.
No problem, Shirley.
The formula told me how many cubic centimeters are in the new one, and we can count the cubic centimeters in your old one. We can even use this photo cube to scoop, so it'll be easy to calculate.
Don't sweat it, Shirley. I can tell that this one's bigger.
It'll be easier to take this one back to the store if we haven't put any water in it.
We won't need to take it back. Let's just pour.
Pour this into that?
Yeah, give me a hand.
Wait a minute.
Listen, I can tell that this one's bigger. Trust me.
It's your aquarium. I don't believe it. They're the exact same size.
Sorry.
This program was supported in part by the National Science Foundation, under the supervision of the Agency for Instructional Technology, AIT.